All right, boys and girls, welcome back to the drive-through. I don't even know. Special shout out to all the local squads that did so well in the NCAA tournament. Even though the tournament's still going, I think all the local teams are now out. But it was good. They were. Xavier, UK played awesome. That was the best game of the weekend yesterday. And obviously NKU put up a fight while we were gone, and UC did really well too. So it was all good. Okay, so volume. Volume is, if you want to understand this, all you need to do is understand is how we measure it. Okay? So volume is measured in some sort of units cubed. But that's, I think, maybe where you get confused. You really should consider that cubic units. So we might measure the ocean we measure the ocean in gallons or kilogallons, but really you might measure the ocean in cubic miles because the ocean's huge. You might measure the volume of air in your house in cubic feet. You need to know how much space is in a room so that you know how big of air conditioning units and heating units that you need to to fill that room. For example, this school is extremely difficult to heat and air condition. Do you know why? Because of the gym, the commons, and the hub. Think about that. Those are three humongous volumes that don't have huge areas. You know, the floor fits like 400 kids, but it's 3 stories high. And it's not like you can just keep the bottom 10 feet cool. So you have to air condition that entire space, even though it's got a very limited amount of floor. So in that sense, it's a very inefficient building because you have a lot more volume than you have floor space, if that makes sense. Another way to think about that is if you just put a level, 2 ceilings on top of all 3 of those places, you could have a tremendous amount of rooms added without adding any volume to your building. Okay? So we measure volume in cubes. So first thing I want to do is just very quickly redo that picture that I drew for you earlier. Okay? And I want you to know that the reason why the volume of a prism, so here's our first note of the day, is length times width times height, is that we are simply adding up how many cubes could fit in this thing. So if we, if we just divided this thing up into cubes, here we go again. Let's fix this. Let's fix this while we can. Okay, that's a little better. And then let's say so this would be 4 by 6. Okay? So if you think about it, there's one. There's another one. I'm just trying to fill these in, but it's going to be hard to see. So every time we cross this thing, we would make more and more cubes. Let me just color this one little cube in. So to figure out how many of those cubes are in there, and this looks like this would be 1, 2, 3, 4, we would do, there are 4 sets of 24 cubes. Okay, so it's 6 times 4 times 4, which is 96 if we said that this was in inches. 96 cubic inches. Okay, that's how you would write that. Okay? So we only have one more note today to take. We now know the volume of a prism is length times width times height. Hopefully you already understood that. So then what's the volume of a cylinder going to be? Again, my hope is that you don't need to memorize these. Because volume of anything that has the same base on the top as it does the bottom, we simply just take the area of the base and then do what? And multiply by the height. Okay? So, what's the volume of a cylinder? Pi r squared times h. And those are your simple notes for today. Now, would you ever expect an even amount of cubes to fit into a cylinder? No, it's going to be multiplied by pi. It's going to be a weird answer. Okay, which is why we need math. You did not need geometry to figure this out. You could literally just count them. You could use arithmetic. The geometry comes in on this. Okay? Boom!